In quantum mechanics, we use a wave function to describe everything there is to know about a particle. For example, its distribution in space. The wave function describes the wave nature of particles. Squaring the wave function gives a probability density, or the likelihood of finding the particle at any given point. A probability of 0 would mean there is no chance of the event happening, and a probability of 1 would mean it's certain. Because the probability is spread out over space, the probability of finding a particle at each point is going to be a value between 0 and 1. If you add up all the probabilities, what you're doing is integrating the function, and the sum will be 1, because it is certain that we will find the particle somewhere along our distribution. The psi star term is the complex conjugate of the wave function, and this whole term is used to essentially square the wave function, but it is done this way because the wave function might be a complex number or contain the number I. Integral quantities are common in quantum mechanics. You often want to find the sum of probabilities over a certain range, and you can write it in a simplified way. This is Dirac notation. On the left, this is the conjugate of our wave function, and on the right is our state. This is the state that the particle or whatever else we're describing is in. If there are multiple states which a particle can exist in, then we can write a linear superposition of states. A and B, the coefficients, are the amplitude of our wave function, and squaring them gives the probability of that state. Schrodinger's cat is a thought experiment where the cat exists in a quantum superposition of states where the states are either alive or dead, because the cat's fate is linked to the random decay of a radioactive particle. The coefficients, in this case 1 over root 2, are the same, since there is equal chance of the cat being either alive or dead. Squaring gives a value of 1/2. So if each state has a probability of 1/2, these add up to 1 as expected. The cat has to be either alive or dead. It's certainly going to be one of the two, and there's no probability of being otherwise.